I thank all my viewers for watching my videos. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We will now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of July 2024. This question is from the section Analysis, and the question is related to the convergence of the real sequences. This question is from the part C, which is a multiple select question. There can be more than one answer. This question carries 4.75 marks. The question ID is 704061. I thank my student Shripad Venkatesh from CBR College of Engineering, Hyderabad, for participating in the discussions of this problem. Right. The given question is, let an n greater than or equal to 1 be a sequence of positive real numbers. We are given a sequence of positive real numbers, and that is n greater than or equal to 1. Let Bn is equal to an by the maximum of a1, a2, etc. an for n greater than or equal to 1. So Bn is defined as an, the nth term, by the maximum of the first term, second term, nth term, where n greater than or equal to 1. Which of the following statements are necessarily true? We are given 4 options. Option 1, if limit n tends to infinity Bn exists in the set of real numbers, then the sequence n greater than or equal to 1 is bounded. Option 2, if limit n tends to infinity of Bn is equal to 1, then limit n tends to infinity an exists in the field of real numbers. Option 3, if limit n tends to infinity of Bn is 1 by 2, then limit n tends to infinity of an exists in R. Option 4, if limit n tends to infinity of Bn is 0, then limit n tends to infinity of an is equal to 0. Let's now discuss the solution of the problem by taking the options one after the other. First, we have a sequence of real numbers n greater than or equal to 1, where an is positive for all n belongs to n. That means it is a sequence of positive real numbers. Right. We are given Bn is equal to an, the nth term, by the maximum of first term a1, a2, etc. an, the nth term, for each n belongs to n. Agreed. Because each an greater than 0, Bn is also greater than 0. Clearly, Bn is positive for all n belongs to n. Agreed. For a given natural number, small n, belongs to set of natural numbers, we have the maximum of a1, a2, etc. an plus 1. The maximum of the first n plus 1 terms is equal to the maximum of, in brackets, maximum of the first n terms a1, a2, an, comma, an plus 1. Right. So what is maximum of a1, a2, an plus 1? That will be equal to an plus 1 by bn plus 1. This is an plus 1 by bn plus 1. And this is equal to maximum of a1, a2, an is an by bn. So this is maximum of, this is an by bn comma an plus 1. So an plus 1 by bn plus 1 is the maximum of these two terms. So this is equal to either the first, maybe the maximum of these two, maybe the first or maybe the second. So this implies we have two possibilities. This will imply 1. an plus 1 by bn plus 1 is equal to an plus 1. That means you are thinking an plus 1 is maximum for all n belongs to n, or an plus 1 by bn plus 1, the second case, is equal to the maximum of these two is the first one, namely an by bn for all n belongs to n. So there arises two cases. We have to deal with the two cases. Now case 1, let an plus 1 by bn plus 1 is equal to an plus 1 for all n belongs to n. An plus 1 cancels. You will get 1 by bn plus 1 is 1. That is bn plus 1 is 1 for all n belongs to n. Therefore, bn is equal to 1 for all n belongs to n. If in this case, always limit n tends to infinity of bn will be 1. Bn is 1 for all n belongs to n, and thereby limit n tends to infinity bn is equal to 1 in this case. And now bn is equal to 1. Agreed. Bn is equal to 1 means an by maximum of a1, a2, an is equal to 1 for all n belongs to n. That means the maximum of a1, a2, an is an. Cross multiply for all n belongs to n. So the maximum of a1, a2, an is the last term. So that is an. Right. So in the first case, the property of the sequence an is the maximum of a1, a2, an is an for all n belongs to n. The property of bn is limit n tends to infinity of bn is 1. So thus limit n tends to infinity of bn is equal to 1, and the sequence n belongs to n, has the property the maximum of a1, a2, an is an for all n belongs to n. These are the two properties in the first case. So we continue for the further discussion in the next slide. So that's what we have so far. So the sequence an has the property the maximum of a1, a2, an is an for all n belongs to n, and limit n tends to bn is equal to 1 in this case. So we call on the option 1. If limit n tends to bn exists in R, then the sequence an is bounded. Option 2, if limit n tends to bn is 1, then limit n tends to an exists in R. Right. Now we consider an example here because we want to say this is not true. So we consider the sequence an belongs to n, where an is n belongs to n. That means we are considering the sequence 1, 2, 3, 4, 5, so on and so forth. Agreed. Now note that maximum of a1, a2, an is maximum of 1, 2, 3 up to n is n. That is an for all n belongs to n. And we will also see bn is equal to an by the maximum of a1, a2, an is an by an is 1. So bn is 1, limit n tends to bn is 1. So we already have the case 1. In case 1, these are the two properties of the sequence bn and the sequence an should have. So these are these two properties what we have for our sequence, what we have considered, that is bracket n belongs to n. Right. Now see, limit n tends to bn exists, yes, because it is 1, it exists. But the sequence an, that is n belongs to n, is not bounded. 1, 2, 3, 4, 5, 6, so on and so forth, is not a bounded sequence. So the given condition we have, but this sequence is not bounded. Therefore, option 1 is not true. Option 2 is limit n tends to bn is 1, but limit n tends to an is limit n tends to n does not exist. Therefore, option 2 is not true. Right. We move to the next slide for this second case, case 2. Case 2 is an plus 1 by bn plus 1 is equal to an by bn for all n belongs to n. Right. So we consider case 2, that is an plus 1 by bn plus 1 is an by bn for all n belongs to n. Right. Now an plus 1 by bn plus 1 is equal to an by bn. That means the index, the suffix is reduced. It is n plus 1, it is n here. So an by bn will be, repeat that, an minus 1 by bn minus 1. It is reduced by 1. Is equal to an minus 2 by bn minus 2. Is equal to etc. etc. a4 by b4, right? a4 by b4 is equal to a3 by b3. a3 by b3 is equal to a2 by b2. a2 by b2 is equal to a1 by b1. But what is b1? b1 is a1 by maximum of a1, that is a1 by a1 is 1. So b1 is 1, so this is a1. So each ratio is a1. So thus an by bn is a1 for all n belongs to n. This implies an is equal to a1 times b by bn for all n belongs to n. Taking the limits on both sides, limit n tends to by an is a1 into, a1 is a constant, multiplied by limit n tends to by bn. Right. Now we call on option 3. If limit n tends to by bn is 1 by 2, then limit n tends to by an exists in R. So now we take limit n tends to bn is 1 by 2. Now limit n tends to by an is what? a1 into limit of bn. So a1 into limit bn is 1 by 2. That is, limit n tends to by an is a1 by 2. It exists and is equal to a1 by 2. This means limit n tends to infinity an exists in R. So option 3 is true. Now go to option 4. If limit n tends to infinity bn is 0, then limit n tends to by an is 0. Now go there. Limit n tends to by bn is 0 and limit n tends to by an is equal to a1 times limit bn. That is a1 into limit bn is 0, 0. So a1 into 0, 0. So limit n tends to by an is 0. So if limit bn as n tends to infinity is 0, then limit n tends to by an is 0. So thus option 4 is also true. Combining all the options, the answer to this question is options 3 and 4. That is the detailed discussion of the solution of the given problem from the section analysis, which is related to the concepts of convergence of sequences. This question, in my opinion, is a difficult question. In the examination, during the examination, getting such an idea is difficult. Now, option 1 and 2 can be thrown out by taking an is equal to n. N belongs to n. Right? And these considerations what we have discussed here, is a very special cases of considering the sequences. Anyway, I am sure that you have understood the solution of this problem. I thank all my viewers for watching my videos. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.